Welcome back. Let's jump right into today's explainer of the source material. Think about a massive steel machine, right? Weighing hundreds of tons, sitting outside, exposed to the freezing cold, the pouring rain. Well, just like us, these industrial giants actually need to put on a coat before they can do their jobs properly. Today, we're diving into the fascinating and honestly completely hidden world of industrial equipment insulation. We're going to break down the exact anatomical layers that go into dressing a giant machine and why it's absolutely crucial for building a successful plant. So let's kick things off with a pretty basic question. Why do giant steel machines need to wear clothes in the first place? I mean, it's solid steel, right? It seems like it should be tough enough on its own. But it actually boils down to two vital things. First, the process itself. Industrial plants deal with chemical reactions that need incredibly specific temperatures to work. Insulation keeps hot things hot and cold things cold. Simple as that. It keeps the whole process efficient. Second, and this is a big one, human safety. These steel vessels get unbelievably hot, easily reaching hundreds of degrees. If a worker were to just brush up against bare metal at that temperature, we're talking about severe, life-altering burns. So insulation protects the machine's process, and it protects the people running it. Okay, but how do you actually dress a vertical steel tower that's towering multiple stories above your head? Enter our essential first step, scaffolding. Now, for anyone new to construction terms, scaffolding is just a temporary structural framework. It's usually made of metal pipes and wooden or metal boards. It gets built completely around the equipment, specifically to give the work crews a safe platform to stand on. That way, they can reach those super high or otherwise totally inaccessible areas. You literally cannot start insulating until this scaffolding is properly set up. Now, what's really wild about scaffolding is the sheer logistical pressure it creates. Because, look, scaffolding isn't just a physical structure, it's a ticking financial clock. It's incredibly expensive to rent and set up all those materials, plus it's super time sensitive. While scaffolding is wrapped around a machine, it physically blocks other construction teams, like the piping or electrical crews, from getting in and doing their jobs. Because of that, there's massive pressure on the insulation subcontractor to finish their work flawlessly and get that scaffolding dismantled as fast as possible so the rest of the project can actually move forward. All right, so the scaffolding is up. Now we can start applying the three core layers of this industrial clothing. It all kicks off with the primary thermal insulation, which is often a really thick material like Rockwool. Then that gets covered by a protective metal jacket, and finally the whole shebang is clamped down with tightly secured metal bands. Out in the field, this first step involves specialized crews balancing up on the scaffolding, carefully wrapping the horizontal pipes in this thick yellowish-brown material. That's your rock wool or mineral wool. I kind of like to think of it as putting a heavy, chunky winter sweater on the machine. It does all the heavy lifting, thermally speaking, keeping that intense heat securely trapped inside the pipe where it actually belongs. But, you wouldn't just wear a wool sweater in a massive rainstorm, right? Well, neither do these machines. Over top of that soft, fibrous insulation, the workers apply this gleaming silver shield. We call this the jacket, and it's typically made from thin sheets of aluminum or stainless steel. It acts exactly like a heavy-duty raincoat, physically protecting the delicate thermal insulation underneath from rain, wind, and just general wear and tear from the environment. Once they're done, these huge vertical pressure vessels just look like giant solid steel tanks to the untrained eye. But now you know you're actually looking at a tailored outer jacket. And if you look closely, you'll spot these horizontal metal lines running all the way around the vessels. Those are the securing metal bands from our third step. They basically act like really tight belts, making absolutely sure the protective jacket stays firmly in place, even if the weather gets severe. So here is the absolutely crucial point. Once this pristine new coat is applied, it immediately faces its arch nemesis on the site, water ingress. Construction sites are chaotic places. While the scaffolding is still up, you've got heavy cranes swinging by, other teams installing steel platforms and ladders right next to these newly insulated vessels. It is ridiculously easy for this fresh, delicate jacket to accidentally get bumped, dented, or punctured. And even a tiny, completely harmless-looking crack can let rainwater seep right inside. Now, you might be wondering, why is a little water such a big deal? Well, it comes down to a terrifying industry term called CUI, corrosion under insulation. Let's compare the two scenarios. Dry insulation means your equipment is safe, efficient, and the internal process is perfectly maintained. But wet insulation? That is a massive risk. If water gets trapped between the hot steel vessel and that thick insulation layer, it basically creates a humid, dark greenhouse. It'll silently and rapidly rust the steel machine from the outside in, and the operators won't even be able to see it happening. It's literally a ticking time bomb for the plant's structural integrity. Because of this severe risk of corrosion, we hit a hypercritical stage, the final inspection. Before anyone is allowed to take down that incredibly expensive scaffolding, inspectors have to thoroughly check the entire surface for even the slightest bit of external damage. They are verifying absolute 100% water tightness. If they find anything, a dent, a loose band, a tiny hole, it has to be fixed right then and there. Why? Because trying to repair insulation damage 50 feet in the air after the scaffolding is gone, it's incredibly dangerous and astronomically expensive. But of course, there is one jaw-dropping exception to this entire scaffolding process. We've talked a lot about building scaffolding around equipment to insulate it. But how do structural engineers handle equipment that is quite frankly unfathomably huge? Well, this brings us to a fascinating plant industry technique called the dress-up method, and it's reserved for massive 1,000-ton towers. To understand why they need a totally different method, we have to grasp the sheer scale of these megastructures. In major oil and gas projects, you can easily encounter vertical towers that are 100 meters high. I mean, that's taller than the Statue of Liberty, and they can weigh well over 1,000 tons. The idea of trying to safely build 100 meters of scaffolding straight up into the sky is just a logistical nightmare. The danger to the workers at those extreme altitudes is way too high, and the scaffolding costs alone would absolutely tank the project's budget. So what's the workaround? The dress-up technique. Instead of standing the tower up and trying to dress it way up in the sky, they actually dress it while it's lying safely horizontally on the ground. The workers build scaffolding around the grounded tower, they put on the insulation, the jackets, even the walking platforms. And only when it's fully dressed is this massive structure carefully lifted into the sky by enormous cranes in one spectacular movement. It's amazing to watch. It truly is a massive logistical ballet to get these structures operating. So the next time you drive past an industrial plant and you see those gleaming silver towers and complex networks of pipes, I hope you'll look past what just seems like solid steel. I really hope you'll remember the tailored layers of Rockwool and metal jackets underneath, the incredible engineering behind the scaffolding in those dress-up lifts, and the meticulous care taken to keep both the machinery and the human workers completely safe. Thanks for joining me on this explainer, and keep staying curious.